Hello everyone, our lesson today is lesson 6, the relation between the tangents of a circle. We have here circle M, AB is a diameter in the circle, and we have here two tangents L and K. And we said before the tangent is a straight line touch the circle at a point. So we get here L is perpendicular to AB and also K is perpendicular to AB. So we have K is parallel to L. Again, if we have AB a diameter and we have here two tangent L and K, L is perpendicular to the diameter AB and also K is perpendicular to the diameter AB. We get the two tangents are parallel, L parallel to K. We have theorem. The two tangents drawn to a circle from a point outside the circle, it's are equal in length. So here we have the two tangents drawn to a circle from a point outside, they are equal in length. So we have here AB is equals to AC. We have some corollaries. Number 1, here we have the straight line. The straight line passing through the center of the circle and the intersection point between the two tangents is an axis of symmetry. So here if we have here point like X, we have here AX is the axis of symmetry of the chord of the tangency. Here we have BC, as we said in the previous unit, BC is the chord of tangency. So here we have AX is the axis of symmetry of BC. What's the meaning of axis of symmetry? Perpendicular bisector, as we studied before. Perpendicular, it means here AM is perpendicular to BC and bisect it. So we have here AM is perpendicular to BC and also AM bisect BC. It means DB equals DC. Okay, so again the straight line passing through the center of the circle and the intersection point between the two chords, the two tangents is the axis of symmetry of the chord of tangency, and we said the chord of tangency here is BC. The second one, also the straight line passing through the center of the circle and the intersection point between the two tangents bisect the angle between the two tangents. Here bisect the angle here, it means this angle equal this, and bisect the angle between the two radii passing through the point of tangency. It means here this angle equal this angle. So if we said here angle 1, 2, 3, 4, it means here measure of angle 1 equals measure of angle 2, and also measure of angle 3 equals measure of angle 4. So we studied here the straight line passing through the center of the circle and the intersection point between the two tangents bisect and perpendicular, it means axis of symmetry in number 1, and here bisect the angle of between the two tangents and bisect the angle between the two radii passing through the point of tangency. Here we have summary. Here in this figure we have here AB and AC two tangents, as we said. So we get AB equals AC, and we get here measure of angle 1 here equals measure of angle 2, and also here this angle equal this angle. Okay, and we get AE is perpendicular to the chord of tangency, so perpendicular to BC and bisect it. And from the tangent, as we said, tangent with diameter or tangent with radius, we get 90 degree. So AB perpendicular to MB as MB is a radius, and also here we have AC perpendicular to MC. And from the two triangles here we get this angle equals this angle star, and here is here. Okay, so we have here this figure is like the summary of the previous theorem and its corollaries. Okay, we have an example. AB and AC touch the circle at B and C. What's the meaning of touch the circle? It means AB and AC are two tangents. AB parallel to EC. Measure of angle A 50. Find measure of angle BDE. We want to get this angle BDE. First of all, we have two tangents intersect outside the circle. So we have here AB equals AC. So let's write first, since AB and AC are two tangents, therefore AB equals AC. What did you notice here? We have here ABC. We said AB equals AC, so we have here an isosceles triangle. Isosceles triangle, it means the base angles are equal. So measure of angle ABC equals measure of angle ACB equals what? 180 minus 50 divided 2. So here in the triangle ABC, since measure of angle ABC equals measure of angle ACB equals what? 180 minus 50 divided 2. It means 65 degree. Okay, so we have here this angle is 65 degree, and here also 65 degree. We want to get this angle. So from parallel, what did you notice here? We have letter Z, alternated angle. We have here angle ABC equals what? BCE. So from parallel, since AB parallel to CE. Don't forget to write transversal, which is complete the figure. Here we have AB parallel to EC, which is complete the figure here BC. So BC is a transversal. So we get measure of angle ABC equals measure of angle BCE equals what? Equals 65 degrees. Okay, so here we have here B, C, E, D. This figure is called what? From the previous lesson, of course, is called a cyclic quad. Why? Because the four vertices lies on the circle, and from the properties of the cyclic quad, each two opposite angles are supplementary. So the measure of angle BCE plus measure of angle BDE equals 180. We said before BCE is 65, so measure of angle D equals 180 minus 65. So here, since the figure BCED is a cyclic quad. Why? Because the vertices lies on the circle. So we get measure of angle BDE plus measure of angle BCE equals 180. So measure of angle BDE equals 180 minus 65 equals 150, and this is the required measure of angle BDE. We have some definitions. The inscribed circle of a polygon is the circle which touches all of its sides internally. So here we have the inscribed circle. Here is the circle which touches all of its side internally. So here we have in figure 1 and in figure 2. Here is the definition. So in figure 1 we have here the inscribed circle of the circle ABC. Here we have the side AB touches the circle at D, and the side BC touches the circle at E, and the side CA touches the circle at F. So we called here the inscribed circle. And also from figure 2, here we have the inscribed circle of the quadrilateral ABCD. We have a remark. The center of the inscribed circle of any triangle is the point of intersection of the bisector of the interior angles. It means here in this figure we have here BM is bisect angle B, and AM bisect angle A, and CM bisect angle C. So here the point of the intersection of the bisectors of the interior angle is the center of the inscribed angle. Okay, the inscribed circle. Okay, so here we have here M is the point of bisector of the interior angles of the triangle ABC. We have another definition. The common tangents to the two circles we studied in the previous unit in the position between circle to circle. We said in the two distant circles we have here 4 common tangents. So we have here tangent L1, L2, L3, L4. So we have here 4 common tangents. L1 and L2 externally to the two circles, and L3 and L4 internally to the two circles. Okay, it's about distant circle. Here we have touching internally. We have 3 common tangent, L1 and L2 externally, and we have only L3 is internally. What about two intersecting circle? We have only 2 common tangent, L1 and L2 externally. Two circles touching internally. We have here 1 common tangent, unique 1 common tangent, and this common tangent is external. In one circle inside the other we don't have a common tangent. Okay, we use this in choose. Okay, in the two distant circles we have 4 common tangent, 2 touching externally, we have 3 common tangent. 2 intersecting circles we have 2 common tangent, and finally 2 touching internally we have a unique common tangent. We have last example. Here we have the tangent AB and AC to circle N, and AD AE to the circle M. Okay, we don't know the length of x and y, the value of x and value of y. First, as we said, we have 2 tangent of the circle N. As we said, 2 tangent intersect outside the circle, so we have here AB equals AC. So here first we have AB and AC are 2 tangents. So we get AB equals AC. Substitution, AB here is x plus 2 equals AC here is 6. It's an equation. Remove 2 in the other by negative, so x equals 6 minus 2. We get x equals 4. So the value of x equals 4. We want to get the value of y. Similar, we have AD and AE tangent to circle M. So here, since AD and AE are 2 tangents, What did you notice here? We get AD equals AE. Substitution, AD here equals what? X plus 2 plus 4. So we have X plus 2 plus 4. All of this is AD. And AE equals 6 plus Y minus 3. Also, it's an equation. So here we have X plus 6 equals Y plus 3. Substitution by x as we said equal 4, so we have 4 plus 6 equals y plus 3, so y plus 3 equals 10. Remove 3, so we get 10 minus 3, it means y equals 7. So the value of x 4 and the value of y is 7. Thank you.